Okay, in lesson 12, we're going to be subtracting fractions.
Let's start with
greater
number 1.
than 1. Now, greater than or equal to 1. First thing I'm going to do, I'm going to show you 3 different methods during this video. But first one, I'm going to start, and I'm going to model 3 1/4. So I'm going to draw 4 boxes, show 4 holes, and since my fractional part of this mixed number is quarters, I'm going to go ahead and split them into fourths. Okay. Now I'm going to go ahead and shade them. Let me change color here. And since we have 3 holes, I'm going to shade 3 of them all the way. There's 1 hole, 2 holes, 3 holes, and 1/4, 1 out of 4. Now, our second mixed number, the fraction is in thirds. So I'm going to go ahead and split this into thirds now. And I'm going to go back to red. Actually, I think I'm going to go to a different color so you can see it. I'm going to go to blue. But I'm going to be splitting it up into thirds. Now I'm doing this horizontally the way we always do our second fraction. So now we can see we have 3 1/4, and I've also made a common denominator now by splitting them into thirds, which I got from my second fraction greater than 1. Now, according to this problem, I'm subtracting 2 1/3. So I'm going to go ahead and subtract 2 holes and 1/3. And I can see horizontally, my 1/3 would be right here. Now, in order to find out what our answer is, I can see that as a whole, we have a 1, 2, 3 by 1, 2, 3, 4. So we know our denominator is 12. And you could also see that because 4 times 3 up here would have been 12. That gives you a common denominator. And counting our squares that are still shaded and left, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our answer would be 11/12. Now that there is a method of using models in order to subtract 2 fractions that are greater than 1. Okay. Now that's the first time I show it, and I'm going to continue on, but I'm not going to show the model anymore. But if this is a strategy that's good for you, use it. Now the second strategy I'm going to show is when we're going to take our problem on B, and I have 3, and I like decomposing the first part of it. 3 plus 2/3 minus 2 3/4. And we're going to use the associative property here, where we know 3 plus 2/3 is equal to 3 2/3. So we know if we swap this around, 2/3 plus 3 is still going to equal 3 2/3 minus 2 3/4. Now what this allows me to do is I can subtract that 2 3/4 straight from the whole, and it simplifies my problem down to 2/3 plus 3 minus 2 3/4. Now the biggest mistake students make, they go 3 minus 2 is 1 and then add the 3/4 in. What they need to do is they need to look at 2 3/4 and say, what should I add to that to get back to 3? And that would be 1/4. So now if we wanted to rewrite this with a common denominator, we know we always go 3 times 4 would give us 12 for a common denominator. Then I can go 2 times 4, which gives us 8. 1 times 3 gives us 3. Okay, let's practice that same strategy again. 8 plus 3 is 11. I've got 6 and we plus keep the same common denominator minus 4 and we have 11 twelfths. And 1/4. And I'm going to go ahead and rewrite this now to 1/5 plus 6 minus 4 and 1/4. So I can subtract that mixed number from our whole, and that leaves me with 1/5 plus, now what do I have to add to 4 1/4 to get to 6? Well, if I add 3/4 to get me to 5, so I'm going to need 1 3/4. Okay, so now let's go ahead and decompose this. We have 1/5 plus 1 plus 3/4. So now I could just add, if I change this around, I have 1/5 plus 3/4 plus 1, allowing us just to add our fractions. So I'm going to come back up top here. Now I have 1/5 plus 3/4 plus 1. And let's just go ahead and add these fractions. 1/5 plus 3/4 equals, and we know 4 times 5 is going to give us 20. I'm going to go ahead and put my 1 in there so I don't forget it as our common denominator. Now I have 1 times 4, which gives us 4, 3 times 5, which gives us 15, and when I add these two fractions together now, I get 19/20 plus 1. So we know our answer now is going to be 1 19/20. And I know this fraction is in simplest form because they're only one number away from each other. So they're not going to be divisible by anything more than 1. And that's the only common factor they're going to have. Okay, on D, I have 6 plus 3/5 minus 4 3/4. Rewritten, it's 3/5 plus 6 minus 4 3/4. When subtracting from the whole, I end up with 3/5 plus, well, 1/4 would get me to 5, and then another 1, so I got 1 1/4 again. So now I'm going to split it up, so I'm just adding my fractions, and I'm going to have 3/5 plus 1/4 plus 1. So we can add these fractions. So 3/5 plus 1/4 equals, well, 5 times 4 is 20. 3 times 4 is 12. 1 times 5 is 5. And that's going to give us 17/20. Now, if you notice, I didn't bring my 1 down, but it's still part of my answer. Okay, I was just adding the two fractions. So I've got to add that back in, so our answer is 1 17/20. Okay, for our next one, I'm going to start by decomposing. I have 5 plus 2/7 minus 4 1/3. And I'm going to rearrange it to 2/7 plus 5 minus 4 1/3, allowing me to subtract from the whole, which gives me 2/7 plus, and I'd have to add 2/3 to 4 1/3 to get to 5, so it's going to be 2/3. Now I want to create equivalent fractions on these, so I know 7 times 3 would be 21, and 2 times 3 would be 6, 2 times 7 would be 14, so it's going to be 20/21. So now I have 20/21 plus 2/7 left. Oh, excuse me, I've already done that. So our answer up here is 20/21. Now, if I were going to check my work on this, I could turn this around and say that 20/21 plus 4 1/3 should equal 5 2/7. So let's go ahead and we have our whole number 4 plus, and let's go ahead and add these two fractions. Now, when I'm looking for a common denominator on this, if I have 3 and 21, if I skip count by 3s, we'd see that 21 would be our least common multiple. And if we multiplied between these two, we'd end up with 63, and that'd be a pretty large denominator to be working with. So now we got 4 plus, and I'm going to create equivalent fractions here, which we know is 21 over 21, and the 20 stays the same. In order to change 1/3 into 21, I can see I have to multiply by 3 times 7 to get 21, so I have to multiply in my numerator by 7. So I'm going to end up with 7 21st. So I'm going to end up with 27 21st. So our full answer is 4 27 21st, which is actually equal to 4 21 over 21 plus 6 21st, which is equal to 5 and 6 21st, which when you reduce this, dividing both of them by 3, you're going to end up with 5 and 2 7ths, same thing. So this answer checked, so we know we did the subtraction correctly. So that's how you would go through and check your work. On F, we're going to split up 8 plus 2/3 minus 3 5/7. So we're going to swap it around, 2/3 plus 8 minus 3 5/7. Now allows us to take it from the whole. We take 2/7 to get us to 4 plus 4. So we're going to end up with 2/3 plus 4 2/7. Now we can just add our fractions. So let's rearrange it so we can add our fractions. It'd be 4 plus 2/3 plus 2/7, which gives us 4 plus, if we want to create equivalent fractions, we know we're going 7 times 3 is 21. 2 times 7 is going to give us 14. 2 times 3 is going to give us 6. Add these together, we have 4 plus, we know it's 21st. 14 plus 6 would be on H, 20. We have 17 1/5 minus 2 5/8, 21st. So I'm going to decompose it. 17 plus 1/5 minus 2 5/8. We're going to swap the whole number around so we can subtract it. Plus 17 minus 2 5/8. Because now we end up with 1/5 plus, well, if I add 3/8 to it, I'll get to 3, and I'm going to need 14 more. So it'll be 14 3/8, because I know 14 3/8 plus 2 5/8 is going to give me 17. Now I'm going to rearrange this, because this is actually 14 plus 3/8 to 1/5. Let's go 14 plus 1/5 plus 3/8, because association property says we can order this in any way we want. We're going to add these two together, so we got 14 plus, and we're going to create equivalent fractions here. Well, we know that 5 times 8 gives us 40. We have 1 times 8 is 8. 3 times 5 is 15, which is going to equal 14, and we know it's 40ths. 5 plus 8 plus 15 is going to give us 23. So 14 and 23 40ths. Question 2. Tony wrote the following: 7 1/4 minus 3 3/4 equals 4 1/4 minus 3/4. Is Tony's statement correct? Draw a number line to support your answer. Okay. I know it says draw a number line. You can do that if you'd like. I kind of like decomposing it. Okay. So let's see. It says 7 1/4 minus 3 3/4 equals 4 1/4 minus 3/4. Now I could go ahead and solve both sides to see. Well, let's see if we can do something. Let's go ahead and use that strategy. So if I did that, I'd have 7 plus 1/4 minus 3 3/4 on this side, which I'll change it to 1/4 plus 7 minus 3 3/4. So I can subtract these two, and I get 1/4 plus, I know 1/4 get me to 4, and then 3/4, so I know that's going to be 3 1/4. And 3 1/4 plus 1/4 is going to give me 3 2/4, which is equal to 3 1/2. Now let's try the other side. Here I can see 4 1/4 minus 3/4. Okay. Now let's go 4 minus plus 1/4 minus 3/4. We're going to swap this around to 1/4 plus 4 minus 3/4, allowing us to subtract from the whole, which is 1/4 plus 4 minus 3/4 is going to give me 3 1/4, which is equal to 3 2/4, which is also equal to 3 1/2. So yes, he is correct. Now it says draw a number line, but that's not one of the strategies we used in class, so I'm not concerned with you using a number line. Okay, question 4 says a carpenter has 10.5 feet wooden plank. He cuts off 4 1/4 feet to replace a slat on a deck and 3 2/3 feet to repair a banister. He uses the rest of the plank to fix a stair. How many feet of wood does the carpenter use to fix the stair? Okay. Well, first I'm going to read it again. So the carpenter has 10.5 feet of wooden plank. He cuts off 4 1/4 feet and 3 2/3 feet to repair a banister. Then he uses the rest to fix a stair. So how much wood does the carpenter use to fix the stair? So now if I'm going to do a tape diagram so I can just keep track of what I'm doing. And I know overall there was 10.5 feet of wood. Then it says he used 4 1/4 feet, and that was used for the deck. Then it says he used 3 2/3 feet, and that was used to fix the banister. And the remaining, which is the unknown, is used to fix the stair. So I can see what I'm going to end up having to do here is I have 10.5 feet of wood, and I need to subtract the sum of 4 1/4 plus 3 2/3 to find out how much the stair was. So I'm going to start off by adding these. So I got 10.5 minus, I'm going to add my whole numbers to get rid of them. That's 7 plus 1/4 plus 2/3. Now I'm going to add 1/4 and 2/3. So let's find a common 1/4 plus 2/3. And I can see common denominator, it's going to be 12, because 4 times 3 is 12. 1 times 3 is 3, and 2 times 4 is 8, so that's going to be 11/12. So now we have 10.5 minus 7 11/12. Now I'm going to take this, I'm going to rewrite it, I'm going to decode it, I'm going to go 10 minus 1/2, 10 plus 1/2 minus 7 11/12. And I'm going to rewrite this in accordance with associative property where I can go 1/2 plus 10 minus 7 1/2. And that's going to allow me to subtract from the whole. Leave me with 1/2 plus, I know 1/2 will give me the 8 and then 2, so it'll be 2 1/2. And I can check myself because 7 plus 2 is 9 and half would be 10. Now I have 1/2 plus 2 1/2, and I can see that we are going to have 3 feet. So this would have been 3 feet for the stair. So he used 3 feet of wood for the